Welcome back. Let's have a look what's going on with polynomials, and we have complex roots. So whenever you have a polynomial, of course we can have cubics, we can have quartics. So in the case of this one, an x squared by an x is the highest power we can get on the function. So this function has a leading term. Let's talk about terminology. A leading term if I multiplied all those brackets out of x cubed. So we're talking about a cubic. Of course it's got all the other terms. Go over to this one over here. It has a leading term. If we multiply all those terms out of a 1x squared by 1x squared, which is a x to the 4, and all the other terms, so this one is a quartic. Now, by its nature, what's going on? A cubic can be of that shape. Of course, it can be the upside down of that shape. It can be stretched out that way. It can be, that's terrible, go up that more, or it can go down that way more. So what can happen is no matter what you're going to do with a cubic, we're always going to have one root. And if it goes all the way up and all the way down continuously, it has to cross the x-axis somewhere, so it has to have one root. So we're talking about a cubic, it can have one root, and then it can have imaginary roots. If we're talking about a quartic can be like a parabola in shape, but it's a more accentuated shape, or it can be the upside down of it, or it can have one of these, what I call a W shape, or the upside down of it. So we could get a quartic where the whole graph happens to be above the x-axis. And it doesn't have to be a nice W shape. It can be quite munted up and munted down and all sorts of twists to it. You can even do things where it comes down, goes across a horizontal inflection and goes up again. There's so much we can learn about quartics. Of course we can turn all them upside down. So let's go to this one here, have a look at what's going on. One of the roots is x equals 1. Let's get the other roots. So for it to be roots, we'll have that equal to 0. So we have x squared plus x plus 2 equals 0. We're back to the quadratic formula because we can't get two numbers that multiply to 2 that add up to 1. So let's make it quick. No, let's slow down. Have this constant thing in teaching of hurrying with senior work. But there's no hurry on the video other than trying to keep it brief so you don't have to listen so long. So that's a minus 1, so there's a equals 1, there's a b equals 1, and there's a c equals 2. And you've got minus 1 plus and minus the square root of this 1 squared, which is 1, minus 4 times the 1 times the c, which is 2. And on the bottom we've got a 2 times a, which is 2 times 1. So what do we have? We have minus 1 plus and minus the square root of 1 minus 8 on 2. So you've got minus 1 plus and minus the square root of minus 7 on 2. I'm going to write those separate as minus a half plus or minus. I'm going to separate the fraction out into its two components. And we've got a square root, we've got a root 7 on 2. And how do I get the I out of the square root? The minus out of the square root, I can write an I there. And let's have a look at what we've got. We've got two roots, minus a half plus the square root of 7 on 2i. And the other root is minus a half minus the root 7 on 2i. So, oops, underlying like I'm doing vectors. So every time you get a complex root to a polynomial, to a cubic, and in a moment to a quartic, there's going to be the positive I version and the negative I version. And they are called the complex conjugates. So every time you get a question, and you know you've got some imaginary roots to it, you're going to get the 2. Now let's have a look at what's going on with a quartic. This will have two roots. Imaginary roots, complex roots, and they'll be conjugates of each other, and the same for those two there. So if I quickly went through the quadratic formula, I've got minus b, which is minus 2 plus or minus the square root of, we've got a b squared, which is 4, minus 4 times a times c, 4 times 1 times 4 is 16, on 2a, which is 2 1s are 2, and then we have minus 2 on 2 plus or minus the square root of, that's a minus 12, so I can write that as a 12, root 12 on 2, and I've got an I there. Of course, we can simplify these to being minus 1. I could then also write that as root 4 by root 3, so that would be 2 root 3 on 2. And again, we get the 2's to cancel. You've got minus 1 plus or minus root 3i, and there's your conjugates. Two roots of that one. We can go to the same process on this, hopefully without silly mistakes. I've got minus b, which will be 1 plus or minus the square root of b squared which is minus 1 squared is 1 minus 4 times AC, 4 times A times C, which is 4, which is 8. Oh, yep. And then we've got on the bottom 2A. So what have we got there? 2 1's a 2. And again, I've got here, just like before, I've got a half plus or minus the square root of minus 7 on 2, which can be written as a half plus or minus root 7 on 2i. So again, we've got a pair of complex conjugate roots. So they say you have a root at minus 2i. That means that you've also got a root automatically at 2i. If they say that you've got a root at 2 minus 3i, that means you've also got a root at 2 plus 3i. And what do they have to do with writing the actual polynomial? So this one will have a root of minus 2i, means it has a factor. And remember, the factors are the opposite of what we have here. So that's an x plus 2i. And it also has a factor, the opposite of what we had there, which is x minus 2i. Okay, then this one over here, if we write them as factors, this has a factor, and here's where you've got to be careful. It's x minus all of that. And you can get very quick at writing it down. So we're going minus what that was, and we're going to go minus what that was. Now we have two of our factors, which you can write as x minus 2 plus 3i as one of the factors. And you can write that as x minus 2 minus 3i as one of the factors. So you can always take the complex roots, take one of them, make it into two of them using the complex conjugate by making the imaginary part the negative of what was before. So this one, the imaginary part, become a positive 2i. When you write them as factors, we write the opposite here and the opposite there. Here we write the opposite here. So it's x minus that, and x minus that. And then you can expand the bracket out and make it maybe a bit nicer form. Hope that helps.